I'm Jeff Stano. I'm Chief Software Architect at Unifocus. We're a small company that does, our primary goal is we deliver labor management scheduling systems. And we've been using Sencha for a few years now to build new mobile applications and desktop applications. I assume you're all here to talk about HATEOAS and hear how what we're doing with HATEOAS. So what is HATEOAS? How many of you guys heard of HATEOAS? Okay, so how many of you have read Roy Fielding's dissertation on REST and HATEOAS, or read anything about what he's talked about? Okay, kind of a complicated dissertation, got a lot of stuff in there, but ultimately what he's talking about is that when he coined the term REST, and this is back in the year 2000, this is like ancient times when you think about the web, he coined it to talk about that REST is this talk about representational state transfer of how do you model your API and your resources and entities so that they move through a different resource structure. So if you look at it, REST is the foundation of the modern web because the modern web is all about linking, hyperlinking, and hypermedia. And so when Roy Fielding was talking about it, he said that REST APIs have different constraints. One of those constraints is that all resources have identifiers. Identifiers in this scenario don't necessarily mean integers, 1, 2, 3, 4, 5. They could be names, they could be UUIDs, they could be anything. You really don't care. They just have to be unique. The other thing is, one of the other REST constraints is that you're going to manipulate your resources, and a resource is an entity. You could kind of use the word in a similar fashion, that you manipulate your entities through a set of different representations. Resources are self-describing. That means that if you think about the web, we have different media types. Each media type is documented, so everybody knows what a JPEG media type is, or a text HTML, an HTML media type is. Each resource type should have a defined media type. One of the things that we have in the modern web is that there's standard ones that have gone through standardization, through standards bodies. Those are obviously, as internal as developers, we don't want to have to go through and try to standardize all our internal media types. So there's standards out there for how you describe what your relationship and your media types are. That's what he's talking about with self-describing. And here's our word, hypermedia as the engine of application state. Kind of a big mouthful. HATEOAS is how we call it. He always jokes, why do you want to work on something that you hate? But that's what it is. More things that talk about HATEOAS. The application is really modeled as an engine that moves the state of resources by picking transformations in the current set of representation. What this means from a practical standpoint is that each resource has a set of data, which is its state, and it will have a set of transformation links, and we call those rels. We'll get into some of that in a little bit, that say what state, this is if I want to move it from like not saved to saved, or I want to delete it or something like that, then you would look up the appropriate rel and perform an operation on it. As you can see, state is the current representation of a resource, and the transitions are the instructions. That's really the instructions how to move a resource from one state to another. Think about hyperlinks in a web page or your link on a form. How do I save the data on the form? I have a link or an href, and I'll do something like post the data or whatever to that. Why do we want to use a HATEOAS-based system? Which we really call this a pure REST system. This would be a level 4 REST system. If you go through, I've got notes in the back. Martin Fowler talks about the different levels. There's 1, 2, 3, 4. 4 would be one that has full media hyperlinking, and that's what we're going to be talking about today. So one of the main motivations is to reduce coupling between the client and server. So one of this is that the client discovers the URLs of the available state transition. It doesn't build them, it discovers them. The server will control that. The client does not need to know how a resource is identified. We don't want to make assumptions on the client that they're numeric and incrementing, or their UIDs or whatever. So we're going to let the server deal with that. Client only needs to know the root URL. So the root URL of something, that's the only thing, and from there we can discover everything we need. There'll be transitions from the root down through the children. Server, one of the benefits we get is the server can change the URL layout without impacting the client. So we could have slash, name, say like slash animal slash dog, and maybe later on it's animals slash, amphibians and whales or whatever. And so you can move it around. The client doesn't care what the URL is because it's not building it, it's getting it from the server. The other thing that's the big benefit is server controls which state transitions are available to the client. So one of the benefits that you get in a practical world is without this kind of ability, you end up sending flags or something over in your data that says, hey, I can do the add thing or the delete thing, or I can have the edit button turned on or this or that. The beauty of this is that we have rels, which are the delete, the add, the edit operations, and the server can decide not to include those rels or include them based on security settings or what the user can do. The client just picks it up and says, hey, I don't have a delete rel, better not show the delete button, or I should disable it or whatever. So that's one of the benefits of doing it on the server side. And if anybody has any questions, just let me know if I'm going too quick. Let me go through, we're going to talk about HATEOAS media types, because I've got to go through some of this. So there's a bunch of different ones, but the three big ones that are out there, if you go search HATEOAS, you're going to see HAL, which is what we're going to be talking about today. There's Siren, which is another one that's kind of similar to an HTML form. They're trying to model HTML forms in Siren. And then collection plus JSON is a very simple one. Everything's just modeled as a collection. And so entity that has one thing, it's still a collection of one. If you notice, these are all, most of these are built by one guy who had standardized them. HAL seems to be, let's go through why we picked HAL. HAL has been widely adopted. There's a lot of libraries, both server side, some client side. That's what we're going to be showing today, is how we've integrated support for HAL into the Sencha Ext JS ecosystem. The format's pretty simple. It's easy to generate and consume. Here's the link for the actual definition of the media type. It's a pretty simple read. The media type's definition is application HAL plus JSON. And the whole point of it is that and I'm going to show you an example here in a minute, is that we have a resource consists of state, which is data. That's the actual data. It has links, which are the available state transitions, and then it has embedded resources. Embedded resources are an optional construct, so that if you have your root URL, you could potentially embed the next set of data over with it, or you could just leave it in the links and you could go get stuff or do whatever. The links, everybody understand what the word rel means? Relationship type? Anybody? Rel? Okay. So hyperlinks you've probably seen their use in the style sheet section, like where you do link rel equals style sheet. And the relation type is just the name of how you relate the thing. And it's actually going to be a standard. There's a bunch of standardized ones, like style sheets are standard and stuff. In our world, where we're building our own internally consumed APIs, normally the rel is going to be a full URL. For, like in our case, we're unifocus.com, and you'll see later, I'll show you some examples. We would be http://unifocus.com/something or other that would describe the media type. The target is the href. That's the actual URL that you would use to do the navigation or a post or a get or a put or whatever operation you're going to be doing on the resource. So here's a simple HAL document. As you can see, it's just JSON, pretty straightforward. It's got, let's see, where's the little pointer thing? Oops, shoot. Oh, I can't get the pointer working. As you see up there, we have name, Isaac Asimov. Everybody read Asimov? Everybody like it? Yep. Well, as you notice, I got the name of the author. This is a basic one. We have a link to self. So every resource will have a link to self. That's me. That's what this document. And if you notice here, it's just a hypothetical slash. Normally, when these come from the server, these will be fully fleshed out. HTTPS : blah blah blah. Like in this case, it might be HTTPS, unipost.com/author/Asimov might be the ID. Might be an ISBN number for the books that he's written. Hard to say. Then if you notice here, we have this books thing. And so this would be a link down to get the embedded books array over on the right. So there's two, and then we have this curry thing going on here. So if you notice in the curry, we've got the name, which is books. Thus, up above, we say books : and the curry is just a short name for that big HTTP rels test.com books rel, because we don't want to have to repeat that all over the place. And so the curry is just a way to have a kind of an alias for the big long HTTP thing. And so by having the rels test.com/books, that's the media type for the book media type on our hypothetical library or whatever we're trying to describe here. The embedded section has books repeated, and it actually has, I just put one book because I couldn't fit it all in here, and Asimov has about 5,000, so we wouldn't be able to get them all anyways. But the book has an embedded section. Now the embedded may or may not be there. It's up to the server. He might decide to put it on there, he may not. So one of the things the client could do is it could say, hey, I want to get the list of books for Asimov, so let me go look in the embedded section for books, the book thing. And if I don't have one, then it's going to have to do a get on the link and make another call. If it had the embedded, we can just go grab the data and load it directly right in there. So now we're going to jump into how we've handled, and I'm going to get into some coding here in a minute, how we're doing Ext JS, how we had to modify it to handle REST. So normally, Ext JS is handling URL building. They kind of build the things on the client side and make some assumptions about how things are going to be structured. They'll typically append an ID, so they just take the ID of the thing and append it to the end, put a slash in front of it, and call it a day. That's great if you want them to do it, but if you want the server to control those URLs, I can't have Ext JS building URLs. We need to have it do a different thing. And so as I said, the client hard codes URLs, and we might have to determine state transitions through other means, like how do we do a delete? I don't know, we're going to have to hard code it in the app or something maybe. And how do we know that we can do a delete? We'll have to have a flag. And so it's not handling the Hypermedia portion of REST. So when they have their REST, when in ExtJS, when we have the REST reader and all those things, it's not actually handling REST. It's really REST level 3. Oops, too fast. So one of the things we had to do is we had to extend the Ext data model. I'm assuming everybody's familiar with Ext data model. Okay. So we had to add methods to support the HAL metadata. That's the underbar links and the underbar embedded stuff. The data just kind of comes over like you would normally expect. So you just have your JSON object that just has data in it. One thing you'll find when you start getting into this Hypermedia and HATEOAS world is not all resources necessarily have data sometimes. Like your root resource may not have any data. It might just have a bunch of links to other things for you to go get data. Just depends on what your model is. One of the things we had to do, we had to override the load and save methods so that the load method we had to handle so that we can do additional metadata parsing. The save method, we have to do the opposite, get metadata back on and do things like that. We had to override the ID handling so that Sencha the ExtJS library doesn't put the ID on the end of the URLs so that we can handle it, because we actually don't need to do anything. The server's already got them pre-formatted. We had to extend the reader JSON class and the proxy REST class to handle some of the setup. We'll go through all that code here in a minute. Let's go into the code. And so I've got a GitHub that's got the code that you're going to see here. All checked up. Let me get back into let me get out of here and bring up some WebStorm stuff. Okay, so I'm going to start with what I did is I've developed, can everybody see in the back? Or you need me to zoom it in? Sure, let me open up. Is that better? Okay, let me close this down here. So this is just a Sencha standard, it's just a modern application that I built. We've also got a package that has all the HAL stuff down here. We'll go through that in a minute. What I want to do is I've just built this kind of simulated little banking app. And so one of the things that we're going to have is here's going to be, I've done this all through JSON files, so I didn't have to write any server-side code. And so what we have is the root URL in this case is main.json. So this would be the root URL that you would hard code into your application. You'll see where this comes into play here in a minute. And so if you notice, we've got a couple pieces of data here. We've got our customer name, the name of the bank. We've got our links section. Normally the server would build all this stuff using some HAL library. You can see how we've got our self, which references back to, if you notice, these are in resources banking. So this references back to itself. We've also have a banking accounts. So if we want to get a list of all the accounts that a customer, in this case, Jim Smith at Digibank, has, then you could do a get on the banking accounts and it'll retrieve some kind of banking account data, which we'll see in a minute. Here's this query thing repeated. You can see we have a query called banking, and it points to this hypothetical relstest.com/banking with this little rel template-y thing here, and we said it's templated true. The template will come into play where the accounts word down below will eventually, you don't really have to care about this, but what's happening is that they're taking the second part of the rel, which is the accounts, and putting it into this template. So the idea with it would be that if you had documentation on the API, you would go to rels.test.com/banking/accounts, and you would see a document that describes the accounts API. It would show the structure of the data, what operations get put, post, delete, patch, those kind of things would be done on it. And the other piece we've seen here is we've got embedded banking account data. And embedded, if you notice this is an object. The keys to that object are the rels, in this case banking accounts. And we've got, one of the things I want to make clear is that embeddeds and links point to other resources, and embeddeds are arrays. If you notice, this is an array, and it's an array of other HAL resources. And so if you notice in here, we've got an account. So each one of these objects in this resource, in this accounts resource, it's got an account number, it's got a type, in this case checking or savings, has a balance, has additional links, and look, hey, there's a self link with an href that's going to point to some kind of account thing that's going to show stuff, and you'll see we've got a second account down here and a third one. And then we've got, so if you drill into like the first account, this 1, 2, 3, 4, 5 checking, it's got a balance 150. This one here again has a self that points back to itself. It now has a bunch of additional relations, transactions, deposit, withdraw, transfer, accounts. So the transactions could be something that's going to say, hey, I want to go get all the transactions for account 1, 2, 3, 4, 5. So what we've done here is we again have yet another resource type that's going to be a transaction resource type. Got a self back to itself, and we've repeated, in this scenario, we repeated these other rels because maybe we want to have them available to us at this resource level. But here we've got, this is one of the weird things that I have to explain. Really if you think about it from a bank, a banking account, you can have an array of transactions, right? So in HAL, this is a kind of an oddity that, well, you would think that the array data would just be in the state of the object, but it's not. It's in this embedded thing. Normally, you put it with the same name as yourself, which is, this case, banking transaction. This is a weird part of the spec. And then you just have your array of all your transactions. If you notice, each of these transactions is yet again another resource with links and queries and state. This case, there's no embedded data because really a transaction doesn't need any, so we don't worry about that embedded, and it really just has a link to itself. And so you're really just repeating this. This kind of gets repeated over and over. There's libraries on on all the different server-side technologies, whether it's PHP, Java, Ruby, you name it, they've got it. There's tons of libraries, some good, some bad. We use Spring internally. Spring has a pretty good library for doing this stuff. So that's kind of the structure of how this data would look coming from the server. So let me go through some of how we use the library. So we've got a package. We've got a package down here that has our HAL model. This is the heart of the changes we had to do. And so we just extend data model. We've added a bunch of helper methods that have documentation. We have like getLink, hasLink. I'll show you usage of these in a minute. LoadLink, getLinks, and getLinks as store, get embedded as array, and so forth and so on. We have the ability to get embedded data in a store. So let's say that I want to just show this list of transactions as a store. Hang on a minute, let me find my data. If I wanted to get this transaction data and just put it in a grid, which you're going to see here in a minute, I would just use the get embedded as store, and because it's in the embedded, I give it a rel name, which in this case I would give it banking:transactions, and it will pull out the rel. I give it a model type, which is in this case, the model type would be a transaction. So this is just a standard HAL model that extends data model, and it's really the only thing we're doing. You work exactly like you do with an Ext data model, except that instead of deriving Ext data model, you derive from this HAL model. Everything that Ext data model does, this does. So we haven't changed any of the semantics of using ExtJS models. And so this would be something, so if we were going to load this, we would give it that type, and so forth and so on. Here's our load, where you can see where we're doing we set the ID out of here. I don't want to get into the details right now. If we want, we can get into that in the QA. So the startup of the application, the usage of this API, one of the things the first thing you have to do when you build your application is you have to register these queries, because the system needs to know how to translate banking colon whatever, because the server is going to end up expanding these queries into these full URLs, and then it just has to know how to map that alias. And so we register the query, and then in this case, when we load up, let me run the app here. Let me show you what I've got. Let me do a hang on, being dumb. And we'll go into the app, and we'll go find our apps and our banking app. And so this is all obviously running off of the JSON files that we have in the application. And so when we go into here, we've got our normal main view, and it's really not doing anything. It's just got a list to an account list. And we have our main controller. And the first thing the main controller does, let me get rid of this, is it extends, it's just normal ExtJS stuff. We bring in our banking models, our account and main, because we're going to need those. And the first thing we're going to do, so here is our hard-coded root URL. And so we say banking model.main.load. We give it the URL, has our standard success and failure functions. So after we successfully load the data, we grab out the customer name and the bank name, stick it in the view model, because if you go over here, we've got Jim Smith digibank accounts. And so if you go to the main view, that's the account list. Yep, here we go. So in the account list, because if you remember the main view, I don't want to get into too much details on the Ext stuff. We've got our main view that really just has an account list. The account list has a little toolbar at the top that puts the name of the customer and the bank name. This is just using standard bindings. And if you note, and as we go back to the main controller, we just did the load on the HAL model. It handled all that stuff for us. Now, if you notice, next thing we want to do after we've got the customer name and bank name out of that main model, or that main resource, is, hey, we need to get the banking accounts because we want them to show up in this grid. So what we've got is we ask the main model, which is a HAL model, for the embedded store, and we want the model types to be banking model accounts, and we want to use the banking accounts rel. So if you go back to this main thing up here, we've got banking accounts. We've got an embedded section, and it's got an array of account resources. That allows us over in the main controller to grab that embedded store. Then we look up our list because we got a reference to our list in the account, and we just set the store to be the account store, and boom, your data shows up. And you could do the, and then that's how you'll do that. Now, if you notice, I want to go in. I want to say, hey, what's in my checking account? So I want to drill in. So what happens here is we've got our. Let me go out to the account list controller. And we're just going to do, a lot of this just gets kind of repetitive. It's similar kind of stuff. But in this case, we want to go grab the record that they clicked on. This is in the account tapped handler. We go grab the account that they've done, which in this scenario is going to be a HAL model, because it's just, here again, it's just an Ext data model. The HAL models are just go into the store as HAL models. So we can call HAL models that we have in the other, in our HAL model library. So we're going to say, hey, I got an account model. Let's call the load link thing. And so the load link is similar to embedded, except that it's actually doing, in this case, a load is going to do a get. And so it's going to do a get operation on the banking transaction rel. And so if we go back to the account one, we're going to see banking transactions. In this case, we're on 1, 2, 3, 4, 5, I believe. That's correct. And when we load this rel, it's going to go grab this href for us and do the get operation, just like you would expect in normal ExtJS type of stuff. And it'll do the load, and you still have to handle your success and failure the normal way. And so in the case of a success, we're going to load a list of all the, we're going to get sent in a transactions model, because we know that it's going to be an array, it's going to be a single transaction object. And we can go ask that transaction model for the embedded store of the actual transactions. So when we go back here, here's our embedded array of transactions. And once we do that, then we just grab this and set this. And if you look at the account transactions view, here again, we have a toolbar with some stuff. And we've got a grid with the actual transactions. And if you notice, the transactions show up. And once we do that, let's see here where we're at, account list controller. That's going to, as you see, we're just grabbing the transaction store off the view model and doing a transaction store. Because what I did here is I just set up a simple binding to say I want to have a transaction store in my transaction model, view model. That way, when I bind it, I can just get it all set up, and it'll just, the store will get bound correctly to the table. So one of the other things that I talked about is the existence of these rels that control what state transitions can occur. And so if you notice on this one, we've got, hey, we have a deposit button, a withdraw button, and a transfer button. Let's go back and say, hey, I want to do this savings, and this one also has those, but now I want to go to this third one. Oh, look, we can only deposit money into this account. We can't withdraw. Maybe there's, maybe it's an IRA and you're not allowed to withdraw right now or something. And so one of the things that we got, if we come back over to our, let me find the, probably, Intel, WebStorm probably closed that on me. Let's see. So if you notice in here, this is 1, 2, 3, 4, 5. It has deposit, withdraw, transfer rels. And this one only has a deposit rel. And so what we've done is we've created in the account transaction model, this is to make some of the binding stuff work a little easier. I just went ahead and created some simple little formulas, can deposit, can withdraw, can transfer. That, and remember, this is going to be hooked in to the transaction view model has an account. And so that's going to be when I drill into this account, when I drilled into the account, that account in the view model on this transaction model, transactions view model, That gets set to whatever that account was. So now I can go get the account, and I can ask it, this is a HAL model again, hey, do you have a banking deposit link? Do you have a withdrawal link or a transfer? And has link will return true or false based on the existence of that rel in the resource. And then over in the, let me go find the view. All we've done is created binding expressions. This is just standard ExtJS stuff where we've got binding expressions. I want to bind hidden to the can deposit in the view model and withdraw and so forth and so on. And so by doing all this rel stuff, I'm reusing, instead of having weird flags that come over that may or may not have names, I'm just using link relations to control the state transition from one state to another. And as you can see, I haven't actually implemented doing these, but one of the things, like let's say that I actually wanted to do the deposit thing, and we wanted to implement that. What we would do is, hang on a minute, let me go find the account JSON, is we would end up doing, in this case, we would know that we would want to do a post on, we're going to have to post a transaction, because a deposit would be a transaction. We would post a transaction resource to the URL that's defined by the banking deposit rel type. And that's how you do it, and then that would just handle doing the actual operation of the modification, because you do a puts, posts, or deletes. Now, one of the things that this is the part where we would call out-of-band information. How do I know that I need to do a post to the deposit or the withdrawal? Well, part of it is that the media type, in this case, the banking deposit media type, API documentation would need to tell us that. It's not going to be obviously apparent just from the resource itself. I'm going to jump over a little bit real quick because I want to just show you real quick. There's a thing called HAL browser that's out there, and a lot of these hypermedia, like if you have Siren and Collection4j, they all kind of have something similar, which is the ability to kind of browse your API to a degree. And so I've got this set up to where I said, it works better when you have an actual HTTP server where you can hit it, where you'd say HTTP : something or other. But I had to hook it in here with the JSON file. So what I did is I said, hey, let's go put this as my root URL, and it's going to show me, here's the properties that came back, and I'm going to do, now this would normally, if you were doing it against a real web server, you would, if you had to log in, you would be required to sign in, anything like that. But you can see here, here's all my rels. I've got a self link, there's my banking accounts. When I drill in, hey, look, there's my account data, came over, my URL changed all automatically. Here's my banking accounts, and here's my embedded resources. I can drill into those and actually see, oh, hey, wait, here's some stuff I can do here. There's links for withdraw, deposit, and so forth and so on. And so you can see by using this HAL browser against a media, against an API that implements HAL, you can see how you can just kind of browse through the API to kind of get an idea of what kind of link properties and different data there are in order to do this. So I don't want to, got to watch my time so we don't get too go over. I want to make sure we have time for questions. So let's see. So but I want to go back to what we did in the package. So what we did is we created a package that encapsulates all this stuff into this little HAL package, and this stuff's all up on the GitHub. And so you guys can grab that. If you have comments or something, you can just hit me up on GitHub. The HAL model, that's the heart of it. The store, let me close up a bunch of this stuff so we can kind of go through real quick. Give a couple minutes, we got a few minutes. So the HAL store, as you notice, really isn't doing anything. We ended up having to override some of these just to set things up correctly, because we need to have a store that could hook up into the HAL model. And we don't use the HAL store that much. It's really just more in the background. We end up setting up the HAL proxy. So if you're familiar with the proxy configs, this just happens all automatically when you pull in HAL reader. And so if you notice in here, we say somewhere in here, there's a don't do stuff with ID. Yeah, append ID false. So that's how we tell ExtJS, hey, don't put the ID on. We're already handling it. Here's our action methods. Here's our headers. These headers will just automatically go over every time. That way you guys wouldn't have to deal with it. And we've got our HAL alias. This way it's all standardized ExtJS. So when you bring this stuff in, it all just kind of gets registered automatically. HAL Reader, this is the one that actually kind of does some of the heavy lifting. The goal of HAL Reader is to parse the metadata, the underbar links and underbar embedded. That's really its only purpose. You normally don't have to deal with this because this is all handled in the background. We got some Curry utility stuff that you don't have to worry about. We have a HAL schema. This is how all this stuff kind of gets linked together. And I'm trying to think. We have the ability to get out links if we need to do get the actual links. One of the things that you could find that we've used is we'll have combo boxes or drop downs or lists or things, usually combo boxes, where we're gonna have a list of different things that all go to, maybe it's a drop down that has different categories or something, and each one of those has a URL. In the standard web definitions for standards for links, links can have additional attributes beyond just href. They can have names and categories, and you can add all kinds of your own stuff. But one of the things you can do, and I think they have a title, if I believe, is you can actually put a title on these links, and they have hrefs. You can populate these things in the combo box, and we've implemented in the HAL model the ability to get links out. Where is that? We have the ability to get links as a store. And so a link object that has a title and an href allows you to get that link store, populate that store in a combo box, all those nice titles that the server generated for different maybe categories or whatever it might be, just show up in the combo box automatically, and you'll have your link. When you click on it, hey, I've got my link. I don't have to hard code anything anymore because I've already got the href because it's in the model on the combo box, and you can just follow the link or do whatever you want. Maybe the link is a different filtering mechanism for a way to filter a grid or something like that. I'm trying to think what else. I think that's about all I've got to show. Any questions? Go back here.
So that embedded, that's more like a lookup, right? So you can get your stuff ahead of time rather than go call.
Right, that would be the purpose of the embedded. Let me go back here, so everybody understands. So the purpose of the embedded section is, like I said before, it's optional. The server might not provide it, just depends. The server's in control, not the client. The embedded is like, hey, I'm gonna provide this because I have a feeling that people are gonna wanna get this data ahead of time. So they can either make a GET call, a second GET call to Books Asimov, or they can say, hey, go grab me the books. And it's just in the embedded. So yeah, the purpose is to get your, it's really kind of, I don't know if I hate to call it a caching, it's just a look ahead. That's probably the best way. Yep. Okay. Any more questions?
Can you show the URL to your GitHub?
To which one? Oh, the GitHub? Yeah, let me see. There's that one. And I think these presentations are, I think they're going to have them accessed somewhere. But yeah. So that all this code's up there. It's got, the HAL package has got Jasmine tests around the whole thing. So it's all tested and everything. We've got documentation. So how many people are interested in HATEOAS stuff? Or how many have you guys used any of it? Anybody used it in the real world? So what was your, how's it working for you? Okay.
But it's good spec in general.
Yeah. So if you guys have used other things, is it all HAL or used other things, or?
It's slightly different. I'm not sure which one it is.
Right. But yeah, the code is easily adaptable to different media types.
So is there any way for us to request something embedded?
From the client side?
Yeah.
Yeah, normally, I mean, the idea with a lot of these, sorry, let me repeat the question. So what he's asking is there a way for the client to request that something be embedded as opposed to doing a GET? And probably the best way to say it is the server's in control, not the client. So normally there would not be something there wouldn't be a way. Now it doesn't mean you couldn't put a query parameter on something that says embedded true false or something if you really felt the need to do that. But you'd have to, the problem is now you're coupling your client to your server, and now the server guy's like, what the heck are you doing that for? You know, so the whole idea is that in reality we want the server to be in control. But how do you do that in a way when you have thick, you know, kind of heavyweight clients? And so that's how we do it.
One thing we use embeddeds for is like if you're wanting to, like let's say you have a list that doesn't need the full resource. Maybe the resource is huge, and maybe you just need the name and a few other details. But the embedded does not have to contain the whole resource. It can contain a sub part of the resource. So a lot of times you'll get the embedded and you just like, let's say you want to fill out a table, and it just has a subset of that resource. And then you can then use the links to actually get the full resource that's in the embedded, because the embedded is going to have a self. So you can just go, okay, well now I want to load myself and get the full thing if the user wants to drill down. So a lot of times when we write these embeddeds, we actually are saying we do have a client in mind. So we'll put the embedded in there for our client. But you might write another client later on that uses the same API, and it doesn't need the embedded. So you're just kind of imposing your will sort of on your clients. Like let's say you have a watch app, the next app you do, the watch can't just shove all the information to the user. So you know, so although it is kind of the REST is kind of like application centric, it is sort of a you know, workflow specific application. It is sort of a reusable API.
Okay. Yes.
Is it easy to mix some resources, some HATEOAS resources with other REST services already existing in the enterprise system?
Okay, so what he's asking is, can you mix, say, like the HAL stuff with existing REST services?
Because it's really hard today to have an enterprise system to have everything to redo from scratch.
Yes, that would be true. It's always hard to redo things. One of the patterns, I mean, technically, yes, you could mix them. It's all just whatever you want to do on the client. Obviously, you can mix the stuff. One of the patterns that we've used very successfully is this concept of a BFF backend for front end. And so the idea is every time we build a new front end, we have a backend for that front end that insulates us from the other guy that you don't control. And so so really you're just adding a level of indirection so that my front end and my back end for that front end they can make remote REST calls or whatever you need to do to this other thing that you don't control. So it allows you to say like, hey, we want to use Hypermedia type APIs for our front ends, but we have to adapt calls. Maybe I need to call Google Maps or something to get data, or weather.com or something. And so I can aggregate that in the BFF. That's how we normally handle those kind of things.
There's nothing stopping you from putting other realms to other systems in the payload as a link.
That would be correct, yeah.
You could link to an image. You know, you might not have, you won't get, when you call that, you got to know that that media type that's coming back isn't a HAL media type, and so it's not going to give you the links, you know, the navigation links that you would get from
Right.
HAL media type. So you got to kind of, and that's where that query comes into play, because that query is a namespace for your rel. It's saying this rel belongs to this banking app. It doesn't belong to your Google app that you're calling, or your other REST call, internal REST.
Yeah, so did you kind of understand what he's talking about there? So let me repeat it. So what he's basically talking about is you can have other links that just point to random things. I could have Yahoo, or I could have a search engine rel and it's got Google in it or something. And it's just, hey, I want to go get the search engine rel, and maybe that's based on a user preference that's stored somewhere. You don't want to have to waste your time. You say, give me the search engine rel, and it returns you back Google, Yahoo, whatever, and you do whatever you need to do. So does that kind of make sense? So, yep. Yes, sir.
Have you got a recommendation about where you use put patch?
Okay. So yeah. So what he's talking about is where do you use put and patch. So in a normal, if you've grown up doing HTTP over a long time, in the old days everybody was git and post, right? Post very RPC. So put and patch. We haven't used patch much because really patch is more of kind of like a partial update. But we would do, whenever you do edit operations, so let's say you're going to edit a transaction, let's just say for fun in our banking app, I would normally expect to do a put, not a post to that operation. If I'm creating a new transaction, I'd expect to do a post. Then the post would come back with the location, and that would give you the location, because you don't know what the ID is. I don't know what the ID of this thing is. I'm not going to make any assumptions, so it can return back the URL of the newly added thing. Does that make sense? And then delete would be obviously the same thing, but
And the HAL model kind of does that for you. When you go save, you'll know that if,
right.
if that thing you previously got on the server that you're editing, because it knows by whether or not it's paying the model, so like how the normal model is Sencha. So if it came from the server and then you do a save on it, it knows to do a put. If it didn't come from the server and you just created a new model, filled it in, and you did a save, then you'll know that it's going to do a post.
So you're always sending the full representation each time when you're doing a put. So
That's correct.
replacing the entire.
Yeah, we always normally send the whole representation over at all times, yeah. And real quick before we run out of time, I've got links for all the things we've talked about typically. The Richardson maturity model link is actually a very good one by Fowler. How many guys you read Fowler? Okay, yeah, everybody should read everything Martin Fowler's written. He's guy's pretty darn smart. He talks about basically the 4 levels of REST, 1, 2, 3, 4. That one's a really good one. The InfoQ article, the Weber REST flow one, I believe that's the hypothetical, how does Starbucks do a coffee order using REST? If you want to know if you want to learn a really good way of how REST works, go follow that link. That's going to show you how they do puts, posts, deletes, patches, heads, everything you could ever want. One of the things that we found, we've got a couple minutes. Any more questions real quick?
I do want to add to that. When we do a save, although we are sending the resource back, it's just the data set. We don't send all the links embedded.
Yeah. So one thing real quick, couple points I want to point out. A lot of people, my first reaction when I came in was like, oh my gosh, this data is like massive, right? There's like links repeated over and over. And well, if you actually go gzip this stuff and you run it through the gzip that you're normally going to do, this stuff compresses like 98% because there's a lot of repetition. And so there really hasn't been any noticeable performance issues from the transfer mechanism that we've seen. Trying to think what other things, had something else I was going to mention. It might have been back here. Got a couple minutes. Yeah, there's HAL specs on there, HATEOAS, I'm trying to think.
What's the performance of the HAL store compared to our normal ExtJS store, since you have the overhead
Of the parsing? It's actually, I mean, to be honest, I don't think there's really that much overhead. If you follow what the Sencha guys have talked about, this is all JavaScript. The JavaScript, if you're on an IE6, it might really blow, but on Chrome and Safari, the JavaScript engines are pretty fast. So doing this little bit, if you look at the code in there, if you go look at it, there's not much code going on, really. It's pretty simple code, so we haven't noticed any overhead related to any of the parsing at all. So I haven't done any actual benchmarks on it, so I can't say definitively what that would be. So, okay, any more questions? So, okay. Oh, yep. Sure.
I suppose that opening an authentication token in all the URLs by server orders shouldn't be too difficult.
Okay, sorry, I couldn't hear.
Sorry, I'm French, so my.
That's okay.
So I suppose that adding a authentication token on each URL, and of course generating the URLs are generated in the server, but adding this and just duplicating this on each link shouldn't be too difficult. Did you experience this?
So you're talking about adding authentication?
Yeah, like
Okay, so like normally the way I would expect authentication to occur on any web API for that matter is that would be outside of this. It shouldn't, but you've already authenticated at this point normally. That would have been handled by some other layer in the process. These URLs wouldn't normally need to do stuff. Now we would send, a lot of those send cookies and stuff over. Those would just go along for the ride. But
because I would imagine this architecture will suit very well for a stateless
That's correct. That's so.
For that, I need to embed my token somewhere to.
Right. So the way we've handled it, and I can talk more offline. We're done here, but we do have, like in our world, we have an authentication token that goes in as a header. There's a cookie across the whole application, and we just grab that as needed. So okay. Well, and here's the survey link. So if you can do the survey, that'd be great. And appreciate your time.